Welcome to the second part of the video. So for this subtopic, we will learn about curve sketching. There will be two functions. First one, polynomial function. Second one will be rational functions. So sketching up for the first one, we're going to sketch a polynomial function. So generally, steps for curve sketching as follows. There are 6 steps altogether. The first steps is to determine the domain of f, and then the second one, determine the intercept pintasan if exists. And number 3, by using first derivative test, you need to find all the stationary points or the critical values. And number 4, determine the relative extremum points. Relative extremum mean you have two relative maximum and relative minimum. And then number 5, find the second derivative to determine the point of inflections. And lastly, you can sketch your graph. Example 1, sketch the graph of this function. So according to the 6 steps previously, the first step you have to find the domain of the function. Of course, for the polynomial, this is the polynomial function. You will have your domain as start from negative infinity until infinity. So this is the domain. And then the second step is to find the intercept, y-intercept or pintasan paksi y. Pintasan paksi y means your x value equal to 0. So when you have x value equal to 0, you substitute this into this function, you get your y equal to 2. So that is your pintasan paksi y. Then step number 3 is using the first derivative to find your critical values over here. So from this function, you're going to first differentiate it, then equal it to 0. So you get your x value over here is 1 over 3 and x equal to negative 1. Again, the fourth step is to determine the relative extremum point, which you can again use the table. Previously, we have obtained our critical values in this, and we also obtained our domain start from negative infinity until infinity. So we're going to divide the intervals into 3. The first one start from negative infinity until negative 1. And then start again negative 1 until 1 over 3 and 1 over 3 until infinity. Okay, now you're going to test the value. Pick any x value within this interval. Again, from this value, you're going to substitute it into the f prime function, the first derivative. Substitute into the first derivative, you will get either positive or negative values. So for positive mean the function is increasing function. For negative means it's decreasing function, and positive again increased function. So now you can find your relative maximum from here. Since you already have these two values, the relative maximum for when x equal to negative 1, you substitute into the f. So you get 5. So now you have a complete point, which is point negative 1 and 5. Negative 1, 5. 5 here is your y values. And relative minimum, you're going to substitute x value equal to 1 over 3 into your f function. Then you get the y value. So now you have 2 points, this and this. So the fifth step, you're going to find the inflection point using the second derivative. So from the previous first derivative, we obtain the second derivative, which is this, and then we equal it to 0 to get the x value. And here you get the x value is negative 1 over 3. Again, this x value you're going to substitute into the f function, the original function. Then you get the y value. So your inflection point is negative 1 over 3, 3, 2, 9. Okay, this is your inflection point. Now sketch your graph Basically, you can guess how your graph look like from this table, the previous table. So since this is increasing from negative infinity until negative 1, it's increased. So this is the path from negative infinity until negative 1 here. This is increasing, and then you can see that negative 1 until 1 over 3, negative 1 until 1 over 3, the curve is decreasing here, decreasing. And then again from 1 over 3 until infinity, it's increase. Again, it increase here. Okay, so that's how your graph look like. But don't forget to label your graph, and with all the information you have obtained. Of course, this is your inflection point here, this one, negative 1 3 3 2 9. This is your inflection point. This will be your relative maximum over here, and this will be your relative minimum. Example 2, sketch the graph of this polynomial function. So first you're going to obtain the domain. Again, domain for the polynomial function, of course, start from negative infinity until infinity. Then second step, you're going to find the y-intercept, pintasan paksi y, which means that your x value equal to 0. So when your x value equal to 0, your y equal to 1. Then the third step is using the first derivative to find the critical values. So from here, you're going to find your first derivative, which is this, then you equal it to 0. Then you found your critical values that are x equal to 0, 1, and negative 1. There are 3 values. Okay, the fourth step is to find the relative extremum point. So again, use the table and then divide your interval wisely. So your interval start from negative infinity until negative 1, and then start from negative 1 until 0, again 0 until 1, and then 1 until infinity. Okay, then you're going to test the value. Pick any value within this range, and then these values over here you're going to substitute into the f function. I'm sorry, the f prime function, the first derivative, to check whether you get positive or negative. Remember to substitute into the first derivative, okay? That is for relative extremum. So you in here you have positive, negative, and negative. What does it mean by this? Positive mean the function will be increased, negative mean your function will be decreasing. So next is to find the relative maximum. Since we already know that we have 3 values of x, just now, the critical values of x, you're going to substitute each of it into the f function to find the y value. Okay, the first one is x value equal to negative 1. Substitute it into the function, then you get 4. The y value is 4. So now you have a point over here, 1 point. Then second one, you're going to substitute x value equal to 1, also in the function. Into the function, then you get 4. So you get another point over here, 1 4. So now you have 2 points, and that is relative maximum. Okay, that is relative maximum, and the relative minimum is when your x value equal to 0, your y equal to 1. So this is another point. Okay, how do I know this is maximum and this is minimum? This is because here when you have increase, it's like this, increase, and then when you have here decrease, and again this is increase, and it's decrease. Okay, so this part over here will be your relative maximum. Also this one, relative maximum. And this part over here will be your minimum, relative minimum. This is maximum, and this is minimum. It's quite hard to draw it using computer. Okay, then from this you can guess where your maximum, where your minimum. So in here there are two maximum. One is this, one is this, and only one minimum, which is this 0 to 1. Okay, the next step is find the second derivative to find your inflection point. Of course, for the inflection point, you're going to find the second derivative and then equal it to 0. Then you get this. You will have 2 points. I'm sorry, you will have two x values. One is positive, one is negative. So you're going to substitute each of these into the f function. The first one, f equal to -1 over Z3. You're going to substitute into the f function, then you get a value, y value over here. So now you have a point. Okay, okay, it's easier to write it down in this way. Okay, it's actually the third one. I change it into the perpuluhan or the points decimal, and then we have another x values which is positive 1 over Z3. Again, substitute into the f function, then you get this point. So now you have 2 points, inflection points, which are this. Now you can draw your graph. Okay, so remember again, using this part, you're going to draw your graph. Again, increase mean like this, decrease, increase, decrease. Okay, does it look similar like this? Yes. Okay. Okay, see over here, this is increasing from negative infinity until -1. This is -1, negative infinity until -1, you get increase, the function is increasing, and then from -1 until 0, -1 until 0, decrease, -1 until 0, decrease. Okay, and then again it's increase from 0 until 1, it's increase, and then from 1 until infinity it will decrease like this. So it's quite similar like this lah. Okay, so remember to label your graph, where your minimum, relative minimum, your relative maximum over here, your inflection points. These are the two inflection points over here. Okay. Okay, now we move on to the rational function, how to sketch a rational function graph. So of course we have previously for the polynomial function we have 6 steps altogether, but in rational function you will have 7 steps, one extra step, which is in here, step number 3. Okay, let's recall. The first step is domain, similar with the previous polynomial function, and then the second step you're going to find y-intercept, and second, of course, the x-intercept. Previously you just need to find y-intercept. Now you need to find both y and x-intercepts. And then the third step, this is extra, you need to find the asymptotes. Asymptotes is the garis putus-putus. Okay, and then number 4 is the first derivative equal to 0, and number 5 to find the inflection points using the second derivative, and then number 6 is to determine the concavity and sketch the graph. So let's see example 3. Sketch the graph of this rational function, pecahan dalam bentuk pecahan. So first solution, you need to find the domain. So for domain, the domain for this function is R. Okay, R real number tapi not include negative -1. Untuk semua real number, domain dia adalah semua real numbers tapi tidak termasuk -1. Tu maksudnya dekat sini. Okay, not include -1. Why? Because if we include x value -1, the domain equal to -1, -1 plus 1, you will get 0 over here. We cannot have 0 as our denominator, remember? Okay, so second step is to find your intercept, y-intercept. So for y-intercept, your x value equal to, sorry, when over here we have our function is 0, equal it to 0, so you have your x value equal to 0, 0. Okay, so your intercept is 0, 0. You just substitute your value x equal to 0 and your y equal to 0, so you get this. Then the third intercept is to find the asymptote. This is extra. How do you find your asymptote? From here. Tengok kepada dia punya denominator, x plus 1. X plus 1 equal to 0. So x equal to 1. Like this. X plus 1 equal to 0. So your x equal to -1. Okay? Okay, sorry. How bad it is. Okay, then that is asymptote, vertical asymptote. And then number 4 is to find the first derivative. To find the first derivative so that you can find your critical values. So we differentiate it first using, okay, I'm sure you know how to do this. VU prime minus UV prime over V square, right? The formula in chapter 3, differentiation. So you get x equal to 0 and x equal to 1. You have 2 points over here. Then you're going to differentiate it again to find the inflection point. So you're going to substitute the value over here into the f to check whether it's maximum or minimum. If it is less than 0, then it will be maximum point. Okay, it will be maximum point over here. And for this one, you will have x equal to 2, and then you just substitute it. Does not exist at x equal to -1 because our denominator just now cannot be equal to -1. Again, you use the table, divide your intervals. Start from -infinity until -1. -1 is the critical values you found just now. -1 until 2, 2 until infinity. Okay, then you test for the value and then you make conclusion. Okay, this time around you have to use second derivative because you need to know whether it's concave upward or concave downward. So negative mean concave downward like this. Positive mean concave downward. Again negative and positive like this. So can you imagine your graph? Just connect these three. So you will have graph look like this. So this is concave downward. It's only take this part, not the whole part. Dia cuma ambil yang sebelah kanan ni sahaja kalau tengok. Ni. Sebenarnya dia ada lagi yang di sebelah sini. So dia just ambil yang separuh ni saja. So this is the first part for -infinity until -1. And then jangan lupa we have our asymptote which is -1. So the graph cannot touch this asymptote. And then from -1 until 2. Again it's concave downward. This time dia ambil yang sebelah sini punya. Separuh daripada this graph. Dia ambil yang sebelah sini. Kan sepatutnya dia turun macam ni kan, macam bukit, tapi dia ambil yang sebelah kiri saja. Okay, then we have for the next interval 2 until infinity. 2 until infinity, dia dah dari sini 2 until infinity, dia dah start concave upward. Macam ni. Macam ni. So this is your graph and your inflection point will be here. 2 somewhere around here. 2, 2, 9. 2 over 9 over here. and this is your relative maximum. Don't forget to label your graph. This is the last subtopic, which is rate of change. So at the end of this subtopic, you will be able to understand the application of differentiation as a rate of change. Okay, let's see what we have over here. If y equal to fx, then dy dx is the rate of change of y with respect to x. So we can say that dy dx is a rate of change of y with respect to x. Rate of increase is positive. Rate of decrease is negative. Mean when you have negative value, that is the rate of decrease. Rate of change can be related by the chain rules. Okay, we have learned this before. Dy over dt actually equal to dy over dx times dx over dt. We can say that you want to find the rate of change of y with respect to t. Okay, example 1. A spherical balloon is being blown up so that its volume increases at a constant rate of 30 centimeter cube per second. When the radius is 12 centimeter, at what rate is the radius increasing? Okay. We now have a spherical balloon being blown up. Balloon yang sudah ditiup, that's the volume increase at a constant rate. Okay, so we have V, volume for spherical ataupun sphera, this formula. Okay, again you're going to use all the knowledge you have learned in SPM. So volume equal to 4 pi r cube over 3. Okay, then you have V over here and you have R over here. Now you can find dV over dr. Pi over here is just a constant. R is the variable. So you can write it down like this. dV over dr means that you want to differentiate V with respect to R. So now we're going to differentiate this. You get this 4 pi r square. Now, given that dV over dt is 30 centimeter cube per second, how do we know this? dV over dt. Here, it's given that volume increases at a constant rate. So volume V, constant rate mean T, dt. dV over dt is this. So now you have dV over dr and dV over dt. Now you can use the chain rule, which is dr over dt. Sorry, this dr over dt is what you have to find. At what rate is the radius increasing? So rate means d over dt. Kadar is over dt. Okay. Radius is r. Your r. So we're going to find dr over dt. Red, the radius increasing. dr over dt, from the chain rule, you have dr over dv multiplied with dv over dt. So dr over dv, we already have dv over dr. So dr over dv means 1 over this thing. So dr over dv is 1 over 1 over 4 pi r square. So dv over dt you already found, this one times 30. So another things you have to know is r. How about r? It's mentioned here when the radius is 12 centimeter, means that your r equal to 12. Now 12. Now you have to substitute your r equal to 12 into the equation. Then only you can calculate. So you get this answer. So at what rate is the radius increasing? At this rate, 0.0166 centimeter cube per second. Very small rate. Okay, let's see the next example. The next example, an inverted right circular cone ni cone has a semi-vertical angle. Dia ada angle dekat sini 30 degrees. Okay. Water runs out of a small hole at the vertex of the cone at a constant rate 3 cm3 per second. Okay, dia kata dekat ujung bawah ni, bucu bawah ni ada satu lubang kecil yang mana air mengalir daripada lubang kecil ni dengan kadar 3 cm padu sesaat. 3 cm3 per second. Itulah kadar laju air tu keluar daripada this cone. Find the rate at which the depth h, depth dalam dia ni, dalam dia h atau ketinggian dia. Find the rate at which the depth h of the water is falling when the volume of water is 81 pi cm3. Okay, dia minta kita cari kadar ke dalam, find the rate at which the depth, cari kadar air tu keluar, the water falling. Yang mana dia bagi tahu volume water tu, isi padu air tu adalah 81 pi cm3. So now you have the formula for volume for cone. Okay, volume for cone, if you don't remember, you can Google it. Volume for cone equal to pi r square h over 3. Now you have V, you have R over, okay, so you have this one. Now you have dV over dt. How do I get this dV over dt here? This sentence. Water runs out of a small hole at the vertex of the cone at a constant rate 3 cm3 per second. Dekat sini dia bagi tahu air tu mengalir keluar dengan kadar yang ni. Okay, kenapa negatif? Sebab dia keluar. Air tu keluar, mengalir keluar. So dia negatif. Air tu berkurang. Means kalau berkurang, decrease. Decrease mean the rate is decreasing, means negative. So you have to put negative over here. Then we refer back to our cone, circular cone over here. Dia bagi tahu circular cone has a semi-vertical angle. Ada sudut 30 darjah dekat dalam cone ni. So we have, kalau kita boleh draw triangle dekat sini, segitiga daripada kita punya cone, where tangent 30 degree equal to r over h. Okay, ini actually adalah trigonometry. Tangent 30 degree. This is 30 degree. Tangents mean opposite divide by adjacent. Tangent bermaksud bertentangan bahagi dengan bersebelahan. Your bertentangan or your opposite is r, adjacent is h. That's why you get this. Tangent 30 degrees equal to r over h. Where your r equal to h. Bila kita susun balik, r equal to h over sec 3. Where 30 degrees over here is actually equal to sec 3. That's why dekat sini you have sec 3. Sec 3 or equal to 1.73. We cannot use 30 degrees over here in your calculation because all the calculation will be in radian. Okay, the sec 3 over here is the 30 degrees is already changed into this value, the radian. This is the radian value. Okay, so now if you refer back over here, the volume pi r. Your r now is substitute by this. We're gonna use r equal to h over sec 3. So substitute your r square. So square it, h divide by 3. Okay, so simplify it, you get this one, pi h cube over 9. Remember that volume equal to 81 pi. It is given that volume of water equal to 81 pi. So volume 81 pi ni adalah jumlah keseluruhan isi padu. Kita samakan dengan yang kita dapat dekat sini. So 81 pi equal to 8 pi h cube over 9. Then kita cancel out. Ni boleh potong. Ni boleh potong. Ni boleh potong. Then you get h cube over 9. So this one you boleh solve. So you get h equal to 9. Okay. Okay, then that is only h. We still don't know our the rest, kan? So dv over dh, berbalik semula kepada dv over dh. Where did I find dv over dh? Volume over dh. So previously we have this 3 pi h square over 9. So you get this part. Okay, then you're going to have this dh over dt. Dari mana dapat dh over dt? Ni, find the red kadar. Bila dia minta cari kadar red, means dekat bawah sini must be over dt, at which the depth h of the water is falling. Dia minta cari kadar dh over dt. So we can use the chain rule, which is dh over dt equal to dv over dt times dh over dv. So kita boleh cancel out dv ni, nanti dia akan tinggal dh over dt juga, kan? So dv over dt, you already found dv over dt. Where is your dv over dt? Negative 3. And dh over dv is the one you found just now. Tapi this time, you need to substitute the h value, since you already found your h value over here, 9. So, substitute it, then you get this part. Okay? So, that's all for chapter 4, application of differentiation. So far, we have learned about relative maximum, relative minimum, inflection points, concavity, concave upward, concave downwards, and then you find how to find the how to sketch the graph for the polynomial function and the rational function. Then we have the optimization problem and also this one. Okay, again for the midterm. This time is for chapter 2. Okay, what have you learned in chapter 2? Chapter 2 so far is basic about limits and continuity. So in limits, you need to know when does the limit exist? When does the limit exist? And then does the limit continuous at given point? And then how to find the limit using the lattice formula we have learned in the lecture. What are the lattice formulas? So you're going to figure out that. I wish you all the best for your midterm, whenever it will be. Let's pray for the best. Keep safe, everyone, and I'll see you soon, inshallah. Thank you for watching and good luck for your midterm.